So for lesson 4 in topic 6, we're going to be talking about geometric sequences, and that should sound somewhat familiar to you. We'll talk about that more in just a second. So please open your book to page 127, and 6.4 practice is posted in Schoology. So make sure you do that assignment after you're done watching the video and talk with your teacher as to when that is due. So the first example that you see on page 127, it says, seating plan is being designed for section 12 of a new stadium, and describe the pattern. So let's look at the pattern. So let's look at each row. So in row A, we have 2 seats. In row B, we have 5. And in row C, we have 1, 2, 3, 4, 5, 6, 7, 8. So what happened from row 2 to row 3? Okay, did you add 2? Did you add 3? Yep. And then from row B to row C, did you add 3? Let's see if that happened here in row D. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. And then we added 3 more. So every time we add 3, so describe the pattern, we're going to add 3 seats each row. Okay, now that should sound familiar. Okay, think back to topic 3, and when we talked about arithmetic sequences. In arithmetic sequences, we have a recursive formula where it's based off a sub 1, which is the first term, and then a sub n is a sub n minus 1 plus d. But every single time we add that common difference. And remember, a sub n minus 1, that just means previous term. Okay, so what was the term before it? And then you just add the difference every time. Then we have the explicit formula where a sub 1 is the first term, n is the term number. What term are we on? Okay, and this is the first term, is what that means. And d is the common difference. Now, as you can see, we have a d in both of them. We have an a sub 1 in both of them. Okay, an a sub 1. So we can use those. And then what explicit is so wonderful for is if we want to find the nth term. Like if we want to find the 12th term, we're going to plug 12 in here. We're also going to plug 12 in there. Okay, let's go back to that original problem now. Write an equation for this pattern. So we could do it recursively, and that would be that a sub 1 is equal to 2, and a sub n is equal to a sub n minus 1. And what did we say happened every time? That's right, we added 3. So we could write that equation. But see what it's asking for. It says row Z of section 12 must have at least 12. They want us to go all the way to row 12. Do you really want to count up all those? We only have 5. So that's where the explicit formula is awesome. Okay, so we go back to the explicit formula, and a sub n is equal to a sub 1 plus d times n minus 1. So a sub 1 is 2. The difference we already know is 3, and then we have n minus 1. So if they want us to find out row 12, okay, no, sorry, row Z, not row 12, row Z, and we're at row E. Okay, so if this is row 1 and row 2, what's row Z? That's right, 26. So we're going to find n sub 26. So a sub 26 is 77. So ray sub z, which in section 12, sorry, I didn't mean to screw that out, must have at least 75 seats. Does it? Yep, it does. So if the pattern continues, does the seating plan meet? Yes, it does. So that are arithmetic sequences whenever there's a common difference. But today we get to talk about a geometric sequence. So we're going to talk about a geometric sequence. Now, this is not in your book, so write it in the left-hand column on page 128. In the left-hand column, what is a geometric sequence? A geometric sequence it's a sequence in which each term of the first one is multiplied. That is key. Is found by multiplying the previous term by the common ratio. Okay, so the big important words here is that geometric, you're going to multiply and you're going to have a common ratio. When we looked at arithmetic, we added, instead of multiplied, added or subtracted, and we had a common difference, okay, instead of a common ratio. So multiplying / dividing is what's going to be important. So write that in the left-hand column on page 128. If you need to pause the video, go ahead. So then it says look for a common difference or a common ratio. A common difference is going to be arithmetic. And doesn't it kind of seem, look at that, arithmetic. What did you learn first in arithmetic? Adding and subtracting. A common ratio means multiplying and dividing. We learned that second, okay? And even look, it's alphabetical, arithmetic, geometric. You learned adding and subtracting first, then you learned multiplying and dividing. That might help, okay? So let's see if we can find out what they're asking for now and be able to identify the difference. I am now on page 128 in example 1 in your book. So in each sequence, determine if it's arithmetic or if it is geometric, arithmetic or geometric. Here we're going to add or subtract. Here we're going to multiply or divide. So always check for arithmetic first. See if there's a common difference. So take your calculator and take the 22.2 minus 1. So what do I get? 1.2. If I take 4.84 and subtract 2.2, so I always take second minus first. So the next term minus the one in front of it. Do I get 1.2? Okay, so take 4.84. I think we already know the answer to this, but let's just double check. No, I get 2.64. So it's not arithmetic. We can cancel that one out. So not arithmetic. So now what we do is we find out if it's geometric. Boy, did I write big. So to find out if it's geometric, I'm going to take the previous term, the next term, divide it by the previous. So the second term divided by the first. And I get 2.2. Then I take 4.84 divided by 2.2. Okay? 4.84 divided by 2.2. And I get 2.2. Aha! Let's see if it really works. Try it again. Let's just go drastic. Let's take this one divided by this one. So 23.4256 divided by 10.648. And look at, I get 2.2. So this one is a geometric. Now you might be going, why would you keep on going? Well, because on the EOC, they will say, is it arithmetic, geometric, or neither? So you need to know, is it really geometric? Okay, so B, try that one on your own, go. So you found on this one that there was a common difference every time when you subtracted 75 minus 1, 149, okay? And we could have kept going, but it's going to give us 74. So this one is arithmetic. That's all there is to that, okay? So now, with a geometric sequence, just like with arithmetic, there's going to be a recursive formula. We're going to look at that one first, and then there's going to be a recursive. So remember, A sub 1 just means first term. And R means what is the ratio? And the way you find the ratio is that you take, I always say second term divided by first term. Now, what I mean by that, let's say that I have the sequence of 2, 10, 50, 250, okay? I think that's right. So what I'm saying is that take the second term divided by the first one, or the second term divided by the previous term is a better way to say it. So take a term, that's a better way to say that. Okay, let me erase that. To find the ratio, to find, take a term divided by the previous term. Because then you can use anything. You could have started at 250 and divided by 50. Okay, so you can start anywhere. So here we go. Write the recursive formula for this geometric. So it told you that's geometric and it's recursive. So first thing we do is A sub 1. A sub 1 is 3,000 72. And then before you go any further, look at this. Is this going up or down? Okay, and we just did growth and decay. So you always want to look to see, are these going up and down? This one's going down, okay? So that means that we're going to have a rate that is small. Our rate right here is what we have to find. So a sub n is equal to, we have to find the rate. To find the rate or the ratio, we take a term divided by its previous. So I'm going to take 192 divided by 768. 192 divided by 768. Or wow, why didn't I use 12 divided by 48? That would have been way easier. Okay, so 192 divided by 768. And we're going to get 1/4. We could have taken this one, look, 12 divided by 48. You would have seen that much easier, is 1/4. So my ratio, let's just write that over here, is 1/4. See, my ratio, I guess I could have put it over here. My ratio is equal to 1/4. Okay, so I have my ratio times the previous term. And remember, this is a subscript. This has to go down below the line. So I'm going to overemphasize. Here's A, and this is n minus 1. That has to be a subscript. Don't put it right next to each other, right next to it. It has to be a subscript, has to be down below. Okay, so this is our recursive form. Good. Now the explicit formula for this, and again, you're going, where should I write this? So you're going to write it over to the left. Write it over to the left of example 2. This one's going to be written over to the left of example 3. The explicit form is a sub n is equal to a sub 1 times the ratio to the n minus 1. That's what I sometimes forget, is you have to take n minus 1, not the actual term, but n minus 1. Okay, where n is the nth term, a sub 1 is the first term, and r is the ratio. So what is the 10th term of this? Well, in order to find the 10th term, first we have to find the explicit formula. So and that's what the explicit formula is all about, is to find a specific term. So let's look at it. Well, if I have to plug into a sub 1 is equal to a sub 1, sorry, a sub n is equal to a sub 1 times r to the n minus 1. So a sub n is equal to 8. I have to find my ratio, so I'm just going to take 18 divided by 12. I just took 2, taking a term divided by its previous. Those can both be reduced by 3, so I get 6/4. Whoops, I could have reduced. Yeah, so 3/2. So I could have reduced them both by 6. Okay, so then my ratio is 3/2, so that's what my ratio is equal to. And then to the n minus 1. So if I want to find the 10th term, a sub 10 is equal to 8 times 3/2 to the 10 minus 1 term. So a sub 10, pull out your calculators, okay? And remember, this is you're going to actually find 8 times 3/2 to the 9th power. You have to do this in your calculator first. So 3 divided by 2, so 3/2 to the 9th power. Take that times 8, and you're going to come up with 307.546 blah, 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 blah. I'm going to double check my answer on that. It was right, but they're asking for the 10th term. Okay, and if I'm asking for the 10th term, I don't want to go blah, blah, blah. So I'm going to say that it's approximately that a sub 10 is equal to 307 point. I'm going to round to the nearest hundredth. So I'm going to give it a shove, so 5.5. Remember rounding. This is what I'm rounding to. If this number is 5 or above, I give it a shove. 4 below, I let it go. So that's a sub 10. That's where we're going to use the explicit form. I just realized that that last example was not in your book. So yeah, stick it in, habits of mind, I guess. I'm sorry. Okay, this one is in your book at the bottom of page 128. What is the 12th term? 12th term of the sequence described. Okay, so we're going to want 12 terms. That means that I need explicit. Okay, explicit. Now, the good news is we don't expect you to memorize these because EOC gives you the formulas. You just have to identify what it is. So that's why we just kind of do it that same way. A sub n is equal to a sub 1 times r to the n minus 1. Okay, that's our explicit formula. But look what they give us. Okay, the initial condition is 3. Well, isn't that a sub 1? And a sub n is equal to, look at this, that's the ratio times a sub n minus 1. That is the recursive formula. They gave us recursive, they just didn't name it for us. So now we can just plug it in and we can just find out what the answer is. Okay, so a sub n, we want a sub 12. We're going to plug it in here. A sub 1 is equal to 3 times the ratio, which is 6, to the 12, well, I'm just going to go n minus 1. So that's my formula. Now I'm going to find it for the 12th term. So I'm going to find a sub 12 is equal to 3 times 6 to the 12 minus 1. So 3 times 6 to the 11th. So first find 6 to the 11th. Take that times 3. And we get a huge number. 108,839,1168. And that's just it. You're talking about when you're in geometric sequences, you're going to have big numbers or really small ones because you're multiplying. You're taking something to a power. Remember, exponentials go up really fast. Page 128. What you don't have in your book is this first sentence. See this first sentence where it says that the blog doubles? The blog doubles each week. You don't have that in your book for example 4, and that's what you need. The number of subscribers to a blog doubles each week. How many subscribers will there be in week 9 if the initial amount of subscribers is 10? Okay, so whenever it asks for a specific week, we know we're going to use the explicit. So a sub, why am I calling it A? That should be a G. Usually we use a G for this. I just realized that. So this is usually G sub n because it indicates that it's geometric. Okay, we'll go with what the book is. I'll show you on EOC what I'm talking about. So a sub n is equal to a sub 1 times the rate to the n minus 1. Okay, so let's plug in what we know. We know a sub 1. They told us a sub 1. A sub 1 because the initial amount is 10. What's my ratio? Read the problem again. That's right, it doubles. So it's going to double. That's my rate. It's going to double. And we are on week 9, so we're going to have, so that's just n minus 1. If I'm doing generic, that's what I want to do. Now I'm going to find a sub n, a sub 9, because, a sub 9. I'm going to find a sub 9. So I'm going to plug in 10 times 2 to the 9 minus 1. So 10 times 2 to the 8th, pull out that calculator. And we get 2,560. So the number of subscribers doubles every week. How many subscribers there will be in 9 weeks? 2,560 subscribers. Okay. This one is not in your book, but if you have room at the bottom of example 4, I'd suggest you put this in, or you could put it in down at the bottom or the left-hand column. Go ahead and use that left-hand column. And I'll show you why. This is combining what we learned about exponential growth and decay and also a geometric sequence. So it combines both concepts. You'll see that. The number of people attending the annual Town International Food Festival has decreased by 20% each year since the first year. Okay, write the recursive and the explicit formula. And what it's telling us is attended last year was 1,250. So what is happening here is we have a decay. So we have to look at, first off, what is the decay? Whoops, move that circle. So we don't need that anymore anyway. Okay, so we're looking at the decay. This is a decay because it decreases. Remember that when we do decay, in order to find the factor or the ratio, we're going to have to find, so to find the ratio, we're going to have to take 1 minus the rate. Oh my gosh, look at all these letters meaning the same thing. So hold on a second. Okay. Remember with the decay, what our formula is 1 minus r. Well, that gets confusing because now we're going to use r here as a ratio. But we still have to take this and subtract. Okay, so we're going to take 1 minus 20% in order to come up with r in this situation, which means ratio. Bad choice in math, wasn't it? So we get 0.80. That's what we're going to use for R. And then we're going to write our recursive formula and our explicit formula. So that's R. We know that our initial amount is 1,250. Go, write the recursive and the explicit formula. So the first thing you have to do is you have to find the general form. So I went back and found the general, wrote out the general form. Okay, so A sub 1, they told us, is 1,250. And the rate, they told us, or we found, because we took 1 minus 20%, is 0.80. So that's how I'd find the recursive. So now plug it into the explicit, because that's where I'm really going to find out what I need. A sub 1 is 1,250 times a rate of 0.80 to the n minus 1. So as you can see, a decay is actually a geometric sequence. We just have to find out what that 1 minus r is first. Okay, so that would be our general formula. Now it says, if the trend continues, what will the attendance be in 10 years? To take the explicit formula and find A sub 10. Remember, that's 10 minus 1, so the 1,250 times 0.80 to the 9th power, go. So it says, if the trend continues, what will the attendance be in 10 years? So this is what we came up with, 167.77216. Well, attendance is people. We don't have 0.7 of a people. So you could round it either way. If you're rounding, it would be 168. If not, 167. Me personally, I would take either one. I would probably be okay with either, but that's where your teacher might have some more information on how they would want you to do that on a test or a quiz. So that would be the attendance. It declined. In 10 years, it went from 1,250 down to 167. So that is a huge 20% each year. So that's not good. Okay. Back to your book on page 129, example number 5. The formula A sub n is equal to 1.5 times A sub n minus 1 with an initial value of 40. Describes a sequence, okay? Use the explicit formula to determine the 5th term of this sequence. So what they did is they gave us A sub 1. A sub 1 is equal to 40. And here's my A sub n, right? So that's my recursive formula. And so A sub 1 is equal to 40. And A sub n is equal to 1.5 times A sub n minus 1. So if I want to do, if that's my recursive, I'm going to use my explicit because I want to find a specific term. Then I use A sub n is equal to R times, A sub n, wow, can I try that again? A sub n is equal to A sub 1 times R to the n minus 1. So now plug in what we know. What is A sub 1? 40. What is my ratio? Right here. So if they give us a recursive, we can pull that ratio right out. And then we have n minus 1. That's A sub n. If I want to find A sub 5, you got it? Go. A sub 5 is equal to 40 times 1.5 to the 5 minus 1, or 4. Plug that into your calculator. And you get 202.5. Now let's read the question and see. Determine the 5th term. Yep, we can take that. A sub 5, I wanted to make sure it wasn't like a people thing. This is just a recap of both of them for a geometric. This is for a geometric. And it just shows you both of them in good handwriting. Look at that. And it tells you which each of them are. So you might want to pause it and write this down someplace in your book. It might be helpful. We are now on page 130. The essential questions: how are geometric sequences related to exponential functions? Well, hello, a geometric sequence. Look at its form. A sub n is equal to A sub 1 times R to the n minus 1. It is an exponential function. So how is it related? It is one, okay? Vocabulary: how are geometric similar to arithmetic? Geometric, you're going to multiply, and you're going to multiply a ratio. Whereas arithmetic, you're going to add, subtract, and you have a common difference. How are they similar? Well, they're sequences. They keep on going, and you do something. What's similar is whatever if I have a term here and here, I do something to get from here to here, I do the same thing as I did from here to here. I either add or multiply. Error analysis. For a geometric sequence, a sub 1 is equal to 3. Common ratio is 1.25. Jamie writes this. What did Jamie do wrong? Well, look at the explicit formula. A sub 1 times the rate to the n minus 1. Okay? Where did they put a sub 1? Right here for the ratio. So once again, they flipped it. These people are really struggling. It seems like they always flip the numbers. Number 4, generalize is a sequence geometric if each term of the sequence is x times greater than the preceding. Well, hello, they just add x times. There's your ratio right there. That's your ratio, is whatever x is. That would be your ratio. Okay? So it's got to be geometric because you're multiplying. These next ones are just to make sure you understand what we're doing. So determine whether this sequence is an arithmetic or geometric. Okay? If it is geometric, what is the common ratio? So only if it's geometric. So here we go. What do I do to 30 to get to 6? Well, I subtract. So I take 6 minus 30. I get a negative 25. You can look very quickly that 1.2 minus 6 is not going to give you negative 25. So it has to be a geometric if it's anything. Let's see if it's geometric. So we're going to take 6 divided by 30. That gives me 1/5. If I take 1.2 divided by 6, because remember you always take second divided by first, second divided by previous, okay? 1.2 divided by 6 gives me 0.2. Oh, hey, let's write this as a decimal. 1 divided by 5, wrote it as a fraction, silly me, is 0.2. So what's my common ratio? My ratio is 0.2. That's a 2. Okay, try number 6. So we found out very quickly that it's not arithmetic because when we subtract, we get 1.5 and 6, so not arithmetic. But we also found out very quickly that when we divide 2 by 0.5 and 8 by 2 and 32 by 8, that we found out that our common ratio was 4. On number 7 and 8, we're going to write the recursive formula for each of these. And they are geometric, so we don't have to test to see if they are. We know that they are. So recursive formula, remember, is a sub 1 is equal to whatever a sub 1 is. A sub n is equal to the ratio times a sub n minus 1 times the previous term. So whatever the ratio is times the previous term. Okay, so let's first find a sub 1. That's 640. Okay, and we take 160 divided by 640. 16 over 64. We get 1/4. Okay, and why didn't I do this? The 40 divided by 160, I could have done that without my calculator and gotten 0.25. Okay, so now I have no room to write because I wrote so big. So a sub 1 is equal to 640. Oh, look, no, I can just do this. Subtract off that. Erase that off. And I can just put in the ratio of 1/4 or 0.25. It doesn't matter which one you do. Okay, so try 8. We know that a sub 1 is equal to 2. We just have to find the ratio by dividing a term by its previous term, and we get 2.5. What is a recursive formula for a sequence with an explicit formula? Ooh, so here's my explicit formula. Let's write down explicit formula. A sub n is equal to a sub 1 times rate to the n minus 1 times the ratio times n minus 1. Well, hello, there's my ratio. There's my a sub 1. So recursive is a sub 1 equals what a sub 1 is. And a sub n is equal to the ratio times a sub n minus 1, the previous term. Ta-da! Okay, 10. A sequence has an initial value of 25 and a common ratio of 1.8. How can you write the sequence as a function? Okay, so function, that means you're going to have to use the explicit formula. So if I'm using explicit formula, I'm going to use f of n, okay, and this is going to be a sub n times the ratio to the n minus 1. Okay, so we're going to go a sub 1, which is 25, times the ratio, which is 1.8, to the n minus 1, and we're done. The only difference is we have to change it into a function form. Okay, good. So we have gone through all the notes. please go out and work on practice 6.4. Thank you. If you have any questions, you know where to find us.